All right, welcome back. So continuing on with 3.3, we're going to talk about what a function is. And so a function, the definition is, go back. For every input, which is our x value, there is exactly one output, which is our y value. All right, and so another way that I say this is that x cannot cheat on y. So what that means is each of our x values should only map. If we're doing a mapping, they should only map to one y value. But if we're looking at a table, we should only see our x values in that table once for it to be a function. If we're looking at our graph, for every x value, I should only have one place in our graph where there's a y value for that x value. And so every time we talk about the different ways to determine whether it's a function, we're going to come back to this very expression that for every input there's exactly one output. That's the definition of a function. And then the ways we look at it for the different situations, it's still looking at making sure that for every x there's exactly one y. So like when I look at this first one, my x values, my inputs go to exactly one output, one y value. So this first one would be a function. The second one is not a function. And the reason is because 1 maps to both -1 and 1, and 4 maps to both 2 and -2. And really only one of these had to map to multiple y values for this to become not a function. So that's what we're looking for. We cannot have our inputs mapping to multiple outputs. All right, so which relations are functions? Use a mapping diagram to explain your reasoning. So if I'm just looking at coordinate points, I just want to make sure that my x values never repeat in those coordinate points. But really what this is asking is it is wanting us to go ahead and create our mapping. So 0, 1, 2, 3 for this one, for our x's. And 1, 4, 5, 7 for our y's. And 0 goes to 1, 1 to 4, 2 to 5, and 3 to 7. So because these each map to our x's only map to one y, this is a function. All right, so over here we have -2, -1, 0, 1. Those are our x values. And then our y value is just 0. And so -2 maps to 0, -1 maps to 0, 0 maps to 0, 1 maps to 0. Now, keep in mind, our definition is that every input, there's exactly one output. Each of these inputs only have one output. This is a function. Our x's are not cheating on the y. Now, nothing said that our y could not have multiple, our input or our output could not have multiple inputs. And so that's where our double standard comes in with functions. Y is okay to have multiple x values, but x can only have one y value. So just keep that in mind. It's that double standard. So b is a function even though they all have the same output. Still a function. And one more, we're looking at tables. Is each relation a function? Explain. So when looking at the functions in a table, I'm just making sure that my x values don't happen twice. So here we have 2 1s, which means our 1 maps to 3 and 2. And so this makes this not a function. 1 has both 3 and 2 as outputs. All right, -3, -2, -1, 0. It doesn't matter that all the outputs are the same. I just need to focus on these inputs. They are all different, and therefore this is a function. And we can say something like we did here, like I said, there is no repeat, or each input has exactly one output. We could put the definition of function. If it's something written for me, you can write x doesn't cheat on y, because I understand that. But what it comes down to is for each input, there's one output. 0, 1, 2, 3. There is no repeat inputs, so this one is a function. And again, for each output, there is one input. Simple as that. All right, so that's where I'm going to stop on this one, where we were talking about what is and what isn't a function using both the mapping and the table. The next video, we're going to look at graphs, and we're going to learn what the vertical line test is. And so I'll see you there. On the flip side, 8th grade.